All right, guys. So today we're going to start working on some algebra stuff to get you prepared for that. And what we're going to start with today is graphing lines, but we're going to learn a new form today. So today we're going to be working on standard form. And you already know one type of form when it comes to equations. You know slope-intercept form, and that's y equals mx plus b. So for standard form, the equation looks like ax plus by equals c. And a, b, and c are numbers, okay? So what we're going to do is we're going to take a standard form and convert it into slope-intercept form, just like we would solve an equation. So let's go ahead and start with example number 1. It's going to be negative 6x plus 3y equals negative 9. So when we look at our slope-intercept form, the y is by itself on the left side of the equal sign. So I want to get my y completely by itself. So I'm going to follow the steps to solve an equation to make that happen. So the first thing I want to do is get rid of this negative 6x. So the opposite of negative 6 is plus 6. So I'm going to go ahead and add 6x to both sides. So notice that I didn't line up the negative 9 and the plus 6x because this is a constant and this is a variable. So I can't subtract those or add those together because this would be a box and this would be a circle. So that's gone at 0 pairs. So I'm left with 3y equals 6x minus 9. Now, it almost looks like standard form or like slope-intercept form, except notice there's no number touching the y on our slope-intercept form. So the 3 and the y are multiplying, so I'm going to do the opposite. I'm going to divide by 3. And when I divide on this side, everything is going to be divided by 3. So I'm left with y equals 6 divided by 3 is 2, and I bring my x down, and then negative 9 divided by 3 is a negative 3. So we took our standard form and we turned it into slope-intercept form. Now what we're going to do is we're going to take our slope-intercept and we're going to graph it, all right? So when we graph, remember that we always want to plot our y-intercept first. So if I look at y equals 2x minus 3, this negative 3 is what I want to graph first, and I want to graph that on my y-axis. So I'm going to go down 1, 2, 3, and that's my first coordinate. Then for my slope, for my m, I need to remember that slope is rise over run. And right now it is just a whole number 2, but we know that to make a whole number a fraction, we put a 1 under it. So this is going to be 2 over 1. Now the 2 is positive, so that's going to tell me that I'm going to go up 2. And the 1 is also positive, which tells me I'm going to the right 1. So from this coordinate, from that dot, I'm going to go up 2 to the right 1. Up 2 to the right 1. I'm also going to go in the opposite direction, and when we go in the opposite direction, we do the opposite. So instead of going up 2, I would go down 2, and instead of right 1, I would go left 1. So once I have that, then I can go ahead and I can draw my line that connects them. And when we draw our graphs, we want to make sure that we put arrows on the end of them because that tells me that this graph goes on in both directions. Okay, it's going to keep going in both directions. Let's try another example. So number 2 is going to be x plus 2y equals 8. Okay, so again, I'm going to solve this like a normal equation. I want to get rid of this x first. And right now it's a positive x. So to do the opposite, I'm going to subtract x. So I'm left with 2y equals negative x plus 8. And then I need to get rid of the 2, and it's multiplying. So to do the opposite, I'm going to divide by 2. So I'm left with y equals. Now, for this right here, this negative x divided by 2, I need you to remember that there is an imaginary 1 behind or in front of that x. So this would become negative 1/2 x. And then 8 divided by 2 would give me a positive 4. All right, so we're going to graph this one. We're going to start at our positive 4. 1, 2, 3, 4. Now for this slope, it says negative 1 over 2. So since the 1 is negative, I'm going to go down 1 to the right 2 because the 2 is positive. So down 1 to the right 2. Down 1 to the right 2. And then in the opposite direction, so up to the left, up, and to the left. Once I have enough points, I'm going to go ahead and connect my line. And again, can't forget to add those 2 arrows to the end. All right, let's finish up with our last example. This is going to be example number 3. And it's going to be 3x minus y equals 9. Okay. So we're going to start with our x's. This is a positive 3x. I'm going to go ahead and subtract 3x on both sides. So I'm left with negative y equals negative 3x plus 9. Now, I almost have this in slope-intercept form. The only problem is there's a negative on this y. So just like in example 2, we had an imaginary 1, we have an imaginary negative 1 in front of this y. So that's going to tell us we need to divide everything by a negative 1. That would leave me with y equals negative 3 divided by negative 1 would be positive 3x. And then 9 divided by negative 1 would give me a negative 9. So now that we've converted, we're going to go ahead and plot our negative 9, our y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have 3 as my slope. So to make that a fraction, I'm going to put a 1 under it. The 3 is positive, so that tells me to go up 3. The 1 is positive, so that tells me to go to the right 1. So from my point, I'm going to go up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And just like the others, I'm going to go ahead and graph it with my arrows on the end. So these are the notes for today. Go ahead and keep these with you. You're going to work on the graphing lines assignment, and then you will get your homework after that.